Good morning and welcome to everyone to our second FOGTEC webinar for fixed systems application. My name is Rüdiger Kopp. I've been involved in water mist technology since more than 20 years now. My background is engineering. I've been involved in a lot of research programs related to water mist technology and have been working on standardizations. I'm part of a number of water mist standard committees and work for the company FOGTEC Fire Protection, who is dedicated to this technology, high pressure water mist technology for protection of different application fields, which I will inform you about in a few slides. Today we will speak about water mist technology for healthcare protection. That's the topic of our webinar. But before I come to the topic as such, I want to give you a short overview about FOGTEC as a company. Just a second. Next slide. How do I get the next slide? It's not running. Sorry for this. Sorry for this. How do I get to the next slide? Can you help me with that? Sorry for this interruption. No, didn't. Okay. Right. Sorry for this. Yeah, the agenda of today's webinar will start with a short company introduction, who FOGTEC is, and then I will come to the topic of healthcare protection with the start of the motivation why there's a need for active fire protection systems in hospital environment and other healthcare applications. I will come to the specific benefits of water mist technology in this field and why it has been used in a number of projects all over the world. And I will go through a case study, hospital case study, which I think gives you a good idea where the benefits of the technologies are. Starting with the company, FOGTEC Fire Protection, as a company, we have been founded in 1997 with a focus on high pressure water mist technology. However, we are involved in a lot of consulting projects and in specific fields like the protection of trains and tunnels. We offer the full range of fire protection system, including also the detection part and other firefighting means. Today, of course, we will focus on high pressure water mist technology. This technology we are developing at FOGTEC. We are the manufacturer, the developer of the system. We do a lot of validation of the system, so we are strongly involved into full-scale fire testing, which is the basis for every design of the system. And the integration of the system we are carrying out with system partners. These are expert fire protection companies who also offer conventional technologies like sprinkler, gas extinguishing system, also combined with detection system in the various countries. And they then install our technology, our FOGTEC systems for a specific project where this technology has benefits. We are doing this on a global basis. Our headquarter is in Germany. FOGTEC as a company is a German manufacturer located in Cologne in Germany. We are present throughout Europe, in the Middle East area, in the Far East. Particularly India and China are very well developed market when it comes to water mist. And this is where we have our own entities, our own offices in India and China to support the local market. Now at FOGTEC, today we are talking about the so-called fixed systems protecting buildings and industrial application like machines and other ones like cable tunnels and so on. We have other business units which focus on other fields. One is our rail systems, where we are the market leader in protecting comprehensive system to protect locomotives, but also passenger areas on trains, with a full range of fire detection and firefighting systems. In the tunnel system field business unit, we are providing systems for road and rail tunnels, also combined with detection systems to protect this specific kind of application field, where we have conducted numerous fire tests, large-scale fire tests for this area, where we also have a very good comprehensive range of products. And new application fields are the so-called new energy carriers, so areas where new energy storage means are used. Our focus there is on the lithium-ion batteries in different applications, whether it's power storage or in vehicles, in areas like parking areas and so on, where we have also conducted a number of fire tests and have participated in international research projects to develop our technology around this application field. Now, FOGTEC as a company, we are strongly involved into many institutions who develop standards around the technology. So we are member of all major standardization bodies, whether it's NFPA in the US, the CEN in Europe, VDS in Germany, and others when it comes to development of standards for water mist technology. But we also are part of a number of research projects where this technology is tested for new application fields. And with this one, of course, over the last 20 years, we have protected thousands of different clients all over the world. Here you just see some of the names. So we have installations at these companies in many locations all over the world. But now coming more to our specific application, the protection of healthcare applications, and particularly hospitals and retirement homes are a topic where this technology is used throughout the last years to protect these specific areas. So why is there a need for an active fire protection system in this field? Mostly this is a requirement by legislation because of missing compartmentation between parts of the building. So to make sure that life safety is taken care of and evacuation means are adequate, an active fire protection system can be integrated to the building to compensate missing compartmentation. And this also is particularly interesting for exposed glass facades, for example, and other exposed structures which are strongly influenced by a fire and could represent a risk for people escaping out of the area. And this is where active firefighting systems offer a mean to compensate this risk to increase the safety level into the building. It also is sometimes important that architects, when they build new hospitals, they like to have a very transparent kind of architecture, like you see on the top picture. This is something where an active firefighting system also allows compensation of these very old white spaces where the water mist system or a sprinkler system also in this case makes sure that people can safely evacuate of the area. And in some cases, also an active firefighting system can have cost-saving aspects, particularly when we talk about compensation of structural means. Instead of fire-rated glass, if ordinary glass can be used because of the cooling potential of an active firefighting system, this can, for the entire project, mean that the building can be erected more cost efficiently. So this is the general requirements and need for active firefighting systems. And now the question is, well, what different systems are used? And sprinkler technology generally, of course, is mostly used to protect buildings and to compensate these means. But particularly in the healthcare area and hospital area, the large quantities that sprinkler systems deploy when they are activated means a risk to damage valuable equipment in the area, the analytics units, and also when discharging over a longer period, the water runoff can be a substantial problem into these areas, where a system which uses far less water and is very good in cooling is seen beneficial. And this is the reason why water mist technology, particularly high pressure water mist technology, is seen beneficial in this application field, because with the technology, since the water is applied in a different way, it is atomized into small droplets, and by that it can more efficiently be used to fight the fire. Water quantities can be reduced by 70 to 80%. So we have substantial less water usage, and this of course also is substantial less risk for electric and electronic equipment in the area to be affected by the water discharged. In addition, of course, the less water runoff is seen beneficial. We will come to that on one of the next slides. What also in many projects represent a problem with conventional sprinklers, particularly in projects where the system is retrofitted to an existing building, is that the equipment, the water storage requirements, the piping of conventional sprinkler systems can be quite large, and often is difficult to integrate the system into an existing building structure. This is where water mist, by using far less water, is much more compact when it comes to the equipment. Mostly the system can be supplied from the public water main. So we just have a break tank, an intermediate tank with volumes less than 5,000 liters, so less than 5 cubic meters, which of course far easily can be integrated into an existing building structure. This also refers to the piping of the system. Pipe sizes in water mist technology range between 12 millimeter for the pipe towards the nozzle, and the risers normally are not larger than 60 mil, so it's far easier to integrate these into an existing building structure. In addition, water mist has some other benefits, and I was already mentioning that the system is more efficient than conventional sprinkler technology when it comes to the cooling. Water mist, the principle is that water is atomized into very small droplets, and the exchange with the fire and heat absorbance is via the surface area that is made available. And with these very small droplet sizes, we have a far larger surface area available to interact with the fire. And that's why water mist, although it only uses a fraction of the water of a conventional sprinkler system, it has a much higher cooling effect. So temperatures in the area when there's a fire development and a full fire developed, when the system is activated, temperature dropped from levels of 800-900 degrees to a safe level of less than 50 degrees centigrade within a few seconds or a few minutes. And this, of course, creates a safe environment on the one hand for people to be rescued and to escape of the area, particularly in a hospital. You can imagine people are not so easy to be evacuated, so you are buying more time for the evacuation process. This is certainly seen beneficial by water mist technology, but also, of course, this make sure that services who approach the area and have to finally carry out measures in the area to put out the fire, they have a much safer situation. Yeah. And this, of course, this fast cooling, of course, also limits the fire propagation. So the fire is reduced in size, and the water mist acts like a shield towards building structures, like exposed glass facades, for example, or exposed steel structures, which then allows to use conventional ordinary glass material or steel structures which do not have a cladding around them. So this is where you have this cost-saving potential that I was mentioning. Water mist is a state-of-the-art technology. It has been around since more than 20 or even 30 years, we can say by now. The special about the technology is that the standards require the manufacturers to conduct full-scale fire testing for each and every application. So if a client receives a concept, this is validated for this specific application in full-scale fire tests. So every application field is 100% full-scale fire tested. So it gives a certain safety to the technology, and this is actually unique to water mist technology. The technology in high-pressure water mist field is installed with very durable material. So all the piping is made of stainless steel, but also all other components which are in contact with water are corrosion resistant, which give a long lifetime to the technology. So the life cycle costs of the technology is looking very beneficial, and of course it's environmentally friendly and sustainable technology by using water as a firefighting agent, by using this very efficiently with very low water amount. It is also a very flexible technology, so we have many clients which start to install the system in a specific part of the building, for example, an existing hospital, and then extend the system into other areas. So particularly for retrofit installation, it offers great benefits. The system in a typical building looks like this here. We have normally the pump unit and the water intake into a centralized room in the basement of the building. From there, we have a distribution piping going into the individual protection areas. Per protection area or per level of the building, normally there is a suction valve and alarm valve, which gives a signaling if the system is activated in the individual area, but also allows for further extensions of the system while having the rest of the system fully operational. And the system normally into an application like hospitals or healthcare in general is installed as an automatic system, so a wet system, water-filled pipe, like also in a conventional sprinkler system. And we use nozzles which have a thermal activation, a glass bulb incorporated, so you have a single nozzle activation where the fire has operated the system. So the benefit over a sprinkler system here is also that the coverage area per nozzle is wider than with a sprinkler system. Up to 25 square meter can be covered by one nozzle, and the maximum installation height we have today is 12 meters height. So also in entrance area, atriums into a hospital building, the system can be installed. So the certification behind the system, this is also quite particular. As I was mentioning, there are specific standards for this technology. So the systems are approved and tested to these standards, but these are also giving the general design and engineering parameters for the systems. However, they are different to what you know from sprinkler standards. These standards do not give detailed layout parameters for the system, whether it's the NFPA 750, the American standard, or the European standard EN 4972, or the German VDS. There are more than that, but these are the more common used ones throughout the world. And the difference is that manufacturers like us have to 100% fire test the system for each and every application. Like you see on the photos on the lower side, there you see something for offices, for public spaces, for bedding areas, for storage areas. All these individual risks are individually 100% fire tested, and this finally then leads to a certification and approval. In our case, we have conducted this approval with VDS, the German certification body, which we are using then throughout the world. So that's the approach. Coming to a real case, a case study. We have protected many hospitals in various countries, particularly in Europe. This is a great topic, retrofitting of fire protection system into existing hospital structures. This is also the case in this specific case study. It's the University Hospital in Amsterdam, a very large hospital complex we have here due to the requirements by the local safety authorities. The building had to be retrofitted with an automatic firefighting system. This could have been a conventional sprinkler system, but due to the reason I was mentioning before, a water mist system, a high pressure water mist system has been selected because it's most flexible to be integrated, and it has the lowest interference with the daily operation of the hospital. The challenge in this project has been that the hospital had to remain fully operational during the entire installation process, so it was not closed down, only individual areas were made available for the installation, and this is where the water mist technology really has the benefits to install the system very rapidly. I will come to that on some of the next slides. So into the entire area of the building, into 3 parts of the building and the underground car park area, the water mist system has been retrofitted. In total, we have 34 individual areas on 12 above ground floor and 2 underground floors, where the system is retrofitted with a total area of more than 43,000 square meters. So you see here an overview of the hospital from the top, a top view. The buildings B, C, D have been equipped into the individual floors with the system. The design of the system has been based, as I said, on the full-scale fire test results that we have made available to the design office and to the fire consultants. We do this via a specific manual that the manufacturer has to produce. This is in line to the requirements from the standard, the so-called DIOM manual, that stands for Design, Installation, Operation and Maintenance Manual. And based on this information, which you find in there, combined with the approval certificates, the system has been validated by the local authorities and by the fire consultants, and gave the allowance to integrate the system into the building. It is an automatic wet system that has been installed with glass bulb operated nozzle, as I was mentioning. We are protecting all the nursing areas, all the escape rooms like corridors. Offices have also been protected, public spaces and the car parks in the 3 adjacent buildings. In the escape routes, like the corridors and lift halls, not only the room have been protected, but also the false ceiling have been protected, but because they incorporate quite some fire loads from cabling that is on cable trays, so that required additional protection. The design of the system has been based on specifications that were given by the local authorities. We have 140 square meter coverage area, so this is how the design has been defined for the specific kind of risk area. Each section of the building has a separate shaft where there's a riser from a ring main in the basement of the building, where the water supply is coming into the individual protection areas. So a typical floor you can see here, typical protection area. The implementation of the system is very similar to a conventional sprinkler system. However, the coverage area per nozzle is larger, so we can go up to 25 square meters, as I was mentioning. And the great benefit, particularly into such a retrofit installation, is of course the smaller pipe diameters. As I was saying, the pipe sizes towards the nozzle have diameters, outer diameter of 12 millimeter. The distribution piping has a maximum of 25 millimeters, so it's far easier to integrate this into an existing structure than the big size piping of conventional sprinkler system. In this case, the last part of the piping towards the nozzle has been installed with flexible stainless steel hoses. This is a common approach also with sprinkler technology, but also available for high pressure water mist technology. And of course, in each floor, as I was saying, there in the installation shafts, there is the section valve for each protection area, which allows to close a certain section for repair or for extension, and also gives the alarm if in a certain section glass bolt nozzle has been activated. Now, as I said, the challenging part of the project has been the execution, where it had to be carried out under full operation of the hospital. This is where we have been, of course, in continuous coordination with the client, who always gave us only individual rooms or individual small areas to retrofit the system. So we had a very high degree of pipe prefabrication in this case. We did that as much as possible, but of course in an existing installation we had some local adjustment of this. But the good about it is that this adjustment are carried out by pipe bending, so that very easily they can be carried out on site without causing a lot of noise. So it's a very quiet installation, a very fast installation, and this has been liked by the client. So we are not using great scaffolding or any other construction equipment. So it's really an in and out, which happens in a very short time, a few hours, without seeing that the system has been installed at all. And this is actually what the client was very pleased about. The water supply to the system is by a centralized pump unit. This is located in the basement of the building. This is also typical for all other hospital applications. It's always difficult to find an area in an existing building to locate this pump unit, particularly for a sprinkler system. You have the very large water storage tank, which has also to be incorporated into this area. This is where the high pressure water mist system has its benefit. We have here a system to cover the 140 square meter operational area, which operates 5 pump units of 120 liter per minute at a high pressure. In our case, high pressure means 120 bar at the pump unit. This pump unit is supplied by the fresh water main towards the building via a brake tank, an intermediate tank, a stainless steel tank of only 3,000 liter. And as you can see there on the photo, this is the entire installation of the system on a floor area of less than 15 square meters. So very easy to integrate into an existing building, and this again has been a benefit why the customer has decided for the system. And from this pump unit we have a ring main in the basement area towards the risers in the shafts where the water is distributed and taken to the individual floors. Now, as with any system, once a system has been installed, it's key that the system is also maintained on a regular basis to make sure that it's always operable and make sure that in case it's needed, it also works as it is intended to. This is where regular maintenance is a key point. Water mist technology is maintained to certain standards. Again, the NFPA has a standard for that. That's the NFPA 25, which also includes water mist technology. It's also included in the European standard for water mist, EN 4972. And for example, VDS has also incorporated the maintenance requirements into the VDS 3188. What we can say is that the maintenance requirements and also the intervals are very comparable to those of conventional sprinkler system. However, due to the small equipment, it is quite easy and time saving to maintain the system. And particularly in the project that I presented, all the test valves have been centralized in the basement of the building, so there's no need for the maintenance personnel to approach every individual area, which of course further reduces the time to maintain the system. Now, to summarize what I said, water mist technology offers a certified fire protection solution for hospitals and healthcare applications in general. So it is certified the same way as conventional sprinkler systems for such an application. Now the small water amounts that are needed by the system, substantially less than other systems like sprinkler system, ensure minimal harms to electric and electronic equipment into the building, but also less harm for the building structure, less water runoff in case of an activation. And this, of course, then also reduces the interruption that you would have in case of an activation. So the standby time of the area where the system has discharged is less, which in the end also results in a very positive life cycle balance when you look at the cost of the overall system and operation of the system. Due to this high cooling effect that water mist has, it enhances the evacuation conditions. So particularly in the fields of healthcare, of hospitals, where it takes time to get the people out of the area, water mist with its high cooling creates a safe environment to evacuate the people, but it also compensates heat radiation to building structures like glass or steel, and by that you have chances to reduce the overall cost of the system by this structural fire protection measure that normally would be required. From the integration point of view, as I said, particularly for retrofit application, the technology is beneficial by being very compact, particularly on the piping side and water storage side. And what is seen beneficial by many clients is also that with one technology, water mist, a different type of risk can be protected, because it can also be used to protect transformer areas, generator areas, storage areas for some flammable liquids, for example. So water mist has a broader application range that it can cover than conventional sprinkler systems. So with one technology, the entire building can be protected. So this is where I'm coming to the end of my presentation. Thank you for your attendance, and of course I'm welcome to take any questions that you have. So if you would type them in the questions bar of which you see, you can have on the right side of the your screen. You can just type them in and I will answer them. Otherwise, you can also send us these questions via mail. You see the mail address here on these slides, and yeah, just send us a mail and we will reply to you. So I don't see any questions. So thank you very much again, and hope to see you to our third webinar in this series, which will cover metro protection, a topic that has been around quite a number of years as well, and where water mist also provides a very good solution. Now there's just one question coming in. Yeah, the question is how much and how is the water mist system affected by ventilation and smoke extraction systems, particularly in the basement of the building. This is something where the small droplets, of course, are influenced by ventilation conditions, but this can be taken care of if this is incorporated into the concept, because there are many different type of nozzles that produce different type of droplet distributions, and the right type of nozzle shall be selected for the individual type of risk. This is particularly the case in ventilators areas, like if you have cable tunnels where we have a constant ventilation into that. This is where the system is designed to cope for certain ventilation conditions. I hope I have answered this question. I thank you again and hope to see you soon in the next webinar. Thank you very much and have a good day.